First, a quick refresher on how VORs work. The VOR transmitter sends out two signals, a fixed signal, the same in every direction, and a rotating signal that is out of phase with the fixed one, depending on the direction. A receiver directly north of the transmitter would see the two signals lined up perfectly. The receiver can measure the difference between the two signals to determine where the plane is in relation to the transmitter. Then the receiver compares that radial to the radial chosen on the OBS. If they're a match, the needle will be centered. Another circuit figures out if the radial is within 180 degrees of the OBS setting. If so, a from flag is displayed. If it's more than 180 degrees away, a to flag is displayed, and the needle references the reciprocal of the selected radial. This is all an entirely analog process, with the signal voltages being compared and measured with no microcontrollers or computers. There are several ways to check the accuracy of a VOR receiver, and the easiest is probably a VOR test station if there's one available. A VOR test transmitter doesn't have the rotating signal. Instead, it has two fixed signals, so no matter where the receiver is, it reads as being exactly north of the transmitter. This means the needle will center on a 0 degree from OBS setting, indicating that the receiver believes it is on the 0 degree radial. Just like with any radial, the needle will also center on the reciprocal OBS setting, except with a to flag. Answer A reflects this. For IFR flight, the needle should center with a 0 degree from or 180 degree to indication within plus or minus 4 degrees. VOT equipment isn't at every airport. The list of where they can be found and their frequencies can be found in the chart supplement. A real VOR identifies itself with a 3-letter Morse code ID. A VOT doesn't have an ID. The audio channel just sends either a series of dots or a continuous tone.